what is happening currently in your school?
So we started sequences and series,
Hmm.
and
See,
then we started relations and functions.
okay, so there are multiple tracks happening in your school, no?
Yeah, sure. Yeah.
Okay, so sequence and series is one track, yeah?
Yeah.
This is so what has happened before and what is going to happen next? Give me an idea, like what
Um,
is
we have
sequence and series, the teacher who is teaching this,
yeah.
or what are the chapters that he is doing? Like,
That sir did inequalities.
he
Um,
has done inequalities already.
yeah.
Okay.
That sir has less classes
Okay.
compared to the other teacher.
So
So
he
yeah,
has done inequalities so far, and he is doing sequence and series right now.
yeah, and he's also done sets.
Okay, sets relations also, sets relations and functions.
Relations, yeah.
All three topics have been done, or just sets?
Uh, uh, yeah, the second, so inequality, sets and relations and functions. Uh, uh, the first sir has done. Second sir has done trig,
One second,
trigonometry.
one second, one
Yeah,
second. So
yeah.
in the sets, relations and functions, has he done relations and functions as well, or just sets?
Um, uh, like
Do you know what is a relation, for example?
yeah,
What
yeah.
is it? Tell me.
It's like how the image and the pre-image are related. Like,
Correct.
uh,
But in a mathematically rigorous way, how will you say a relation is do you know this definition? Subset of Cartesian product of two sets.
um, yeah. So like, I haven't really revised because
Uh,
I have chemistry exam on Tuesday,
okay.
so I haven't revised what our sir has done. But yeah, we
Okay.
have done this.
Okay. So this sequence is for board level or JE level? This one, this sirs.
Um, Both.
This is both.
Yeah,
And the other teacher has done trigonometry.
yeah. Like the other teacher has done sequences and series.
Okay, doesn't matter. Trigonometry has been done, and what else?
Um, Trigonometry and yeah, that's it. Like we've done a lot of trig, like like things that are not there in NCRT.
Ratios, identities,
Yeah,
equations.
yeah,
Equations you have done,
yeah.
and properties of triangles.
Yeah, we did that a bit.
Like
Like
sine rule, cosine rule, and all.
yeah, like our sir started that, but
Uh,
then everyone was saying that sir, we're getting tired of trig. Can we do sequences and series?
uh,
So so left that topic and he started sequences and series.
okay. Uh, so basically, these four chapters have been done.
Yeah.
Okay. Fine. Uh, okay. And do you have any idea of what the next topics will be in school?
No, sir.
Okay. And any idea of what their plan is in the sense ki what is the syllabus that they are trying to cover in 11th?
Um,
Right now you are in 11th, no?
yeah.
So in the
I'm not
11th
sure about.
calendar year, what is the thing that they are aiming to cover, finish? What is the plan?
I'm not sure about that. I'm pretty like I think they're gonna just do whatever there is, whatever
Uh,
topics are there in NCRT and the JE
uh,
component of it.
okay. So, okay. So, and they are focusing on NCRT only.
Like
I
we
mean, the
finished
syllabus
NCRT.
wise, they're focusing on NCRT. They might do the JE level for that.
Yeah, we do JE level. Like they've given us a book, and from
Hmm.
there we do JE questions.
Wait, what is the name of the school? This is Matra, right?
Yeah, yeah,
So they have given a book, the JE
yeah,
level book.
yeah.
Okay. Uh, okay, fine. So the problem is that this is a little disorganized. Like there is no plan here. That is what is the problem. Because generally, when you are doing maths and you are preparing for you are targeting JE, no?
Yes, sir. Yeah,
That is your main target, right? because I generally teach for JEE only. I'm not teaching for boards and all. Okay.
Yes, sir.
Because boards and all is super easy, right? You realize that, no?
Yeah.
I mean, it's not super easy, but like it's not like a challenge. Like anybody who is sincere and who is looking through the NCERT and doing the questions will get good marks in boards, right?
Yes,
But
sir. Yeah.
the same cannot be said for JEE. Like even sincere students may not be able to get good marks if they are not preparing in that special way, right?
Yes, sir. Yeah.
You have seen JEE questions and all, no?
Yeah. Like I haven't like gone through any papers yet,
But
but
for the chapter, you would have seen some questions in some chapter, right?
yes, sir. Yeah.
Slightly higher level than, at least
Yeah.
for the mains. JEE mains is slightly higher level than your NCERT,
Yeah. Yes, sir.
and advanced is much higher level.
Yeah. Yes, sir.
So, basically, what is your target here? Like, are you trying for IIT? JEE advanced gives you IIT, and JEE mains gives you NIT. Best case scenario, right?
I mean, sir, I'll try for IIT, but
Uh,
I don't think I can,
why?
like, I don't know, sir.
You
I don't
don't
know
feel
my
like you can get it?
sir, I don't know my capabilities yet. But yeah, sir,
Capabilities.
I'll definitely try IIT. Like
I mean, in 10th standard, you did well, no? 10th standard, how much was your marks in maths and science and all?
in science, it was 90, and then in math,
Uh,
it was
uh.
88 or something.
So, are you not confident about maths, or what is the situation?
No,
Like, generally for you?
like our school gives like
Hmm.
very hard papers,
Our
like
school
no,
means Samatra.
yeah,
Very
like
hard papers when? 11th or before that?
no, like I was in DPS earlier. Now I'm
Hmm.
in a Matra. So they
Hmm.
have like weekly tests. So
Hmm.
1 week it's physics,
Hmm.
then it's math, then it's
Hmm.
chem, then it's computer.
Every week there is a different subject test.
Yeah. And
So,
then like we have a
uh,
normal paper for board, and
uh,
then there's a JE level paper.
okay. So,
For
normal paper happens on which day? Saturday.
no, normal papers and the JE paper, they happen simultaneously, like on the same day.
Like which day?
It's on Tuesdays.
Tuesdays.
Yeah.
Okay. So, how many such tests have happened?
This is the second cycle. Like,
Second cycle means a second semester or something.
yeah, like we have finished
Uh,
like one cycle of 4 tests,
hmm.
and on this Tuesday will be the last test of the second cycle.
So, in the first cycle, for example, how are they scoring out of these tests? What are the total marks and whatnot? First cycle and
Um,
second cycle. Wait.
the first paper I got like 16 on 73 because
First paper is what? Board.
uh, we have like the first paper is JE level, which is
Uh,
from 8 o'clock to 9 o'clock,
uh-huh.
and then the board paper is from like
Hmm.
9:15 to 10:15.
So 1 hour papers, huh?
Yeah,
So in the JE level 1 hour paper, how many questions are there?
they give 37 questions.
37 questions in 1 hour, huh?
No, so there are 25 questions that are only 1 markers, and
Uh,
then 12 questions that are 4 markers. The 12
okay.
questions are higher level than the
1
1 marker.
mark and 12 questions are 4 marks. Do you have all these papers with you?
Yeah, sir.
And you okay, is it shareable like PDF and all?
Yeah, it's a PDF.
Okay. So okay, good. So how much did you get? Like first cycle, some tests. Just give me a set of marks and all.
I got 16 on 73, but like everybody like nobody scored well.
More marks. This one sample size is not good enough. More such marks. How many? Four tests happened, no?
Yeah. So for like and then physics I got 50, then
Physics you
chem
got 50.
yeah.
Okay, and
And
this was 16 was on maths.
yeah.
Oh, these are separate subject tests, so only one maths exam has happened.
Yeah. So, there have been 2 math exams.
So second maths exam,
Uh 27.
same 73.
Yeah.
Okay, excuse me. Okay. So okay. So
Yeah.
right now you're not feeling confident because of these marks.
Yeah.
Okay.
Like there are other people who are like they're very smart
Hmm.
and they've gotten like similar marks. Like not similar.
Highest in maths was what?
Highest was 67. Only one person got above 50,
Okay.
and that was that guy. Yeah.
Okay. Okay, so these just share the you can on the WhatsApp you can share these papers with me,
Yeah.
and if you have done this recently and if you want to discuss, then we can discuss the paper and we'll realize. I mean, I will also figure out what is wrong going wrong and what is the problem. Okay,
Yes, sir.
so right now it is about me knowing you as well. So I need to understand what is happening before we can plan out a good strategy to do things. Okay.
Yes, sir.
So if you can just share these two papers, PDFs on the WhatsApp itself, and I will just take a look and we'll discuss the paper a little bit.
So right now,
Yeah, yeah,
yeah, sir. 1 second.
yeah. You can share on your dad's number only, the same number.
Oh, yes, sir. 1 second.
Yeah.
So 1 second, I'll just ask my
Yeah,
dad to forward it to you.
yeah, yeah.
Yes, so I asked my dad to forward it.
Okay, okay. Yeah, yeah, I can see. This is one paper, okay?
Yeah, so this is the second paper.
Okay. Okay. Okay, so this is a functions paper.
No, so this is
Period and all is being asked. This is functions only, range and period and
yeah,
maximum
so
value.
but they like in our Amatra book that they gave
Hmm.
was under trigonometry, but they hadn't really taught us
Hmm.
uh, relations and functions that time.
Yeah, yeah. This is actually a functions paper, but yeah. Okay, so do you have some problems here that you want to discuss or something? You have an issue in some question or anything like that? Uh,
Um,
these are trigonometry questions mostly.
Yes, sir.
Mm, okay, so everything they have taught, general solution and all, it's all done, it seems. Uh, okay, so I think the problem is that these are all like slightly higher level concepts, and I don't know how much you have practiced all of this.
Yeah, sir.
Okay. So, fine. Trigonometry, basically, a lot of trigonometry is being asked. Okay. Okay. Uh, okay. So, uh, it's just that I think you need a little familiarity with the thing. These are not very difficult. It's just something that you need some practice with. I don't know how much you have practiced. So,
Yeah, sir.
so I would recommend some books for this. So, what books are you using at home for maths?
For math,
Hmm?
like so far, I've been only using the competitive book they have given.
Hmm.
Like there are some questions there, so I do that. And now I've gotten 1 second, sir.
Hmm.
I've gotten some book.
Hmm.
I don't know. It's called Disha or something.
What is the name? Disha. What is the full name of the book?
Objective.
Maths for
Yeah,
JE.
yeah.
Okay. By what writer?
Um,
Is it given? No.
no, sir, only Disha.
Okay. Ignore that. This book you got recently.
Yeah, yes, sir.
Someone told you to get it.
Yeah. So my old math teacher asked me to get it.
Okay. Okay. So there are some textbooks that you need for doing maths properly. So, for example, for trigonometry and for a topic called coordinate geometry that we'll see, these two topics you need to get a book by S.L. Loney. Okay. The book for trigonometry is called Plane Trigonometry Volume 1. Plane Trigonometry Volume 1. And this book is called Elements of Coordinate Geometry. This is also Volume 1. Okay. Uh, these two books are like classic books, 100 years old classics, written in 1890s and all. Okay. So these two books you should order on Amazon today only. Get these two books. These are very cheap and old classics. You need
Okay.
to practice using this. Trigonometry, if you do from S.L. Loney, and coordinate geometry, if you do from here, nothing else is going to be required. It is enough for JEE or whatever you need to prepare for. Okay.
Okay.
Then for algebra, what you should get is there is a book called Higher Algebra by Hall and Knight. That is another classic book, Higher Algebra by Hall and Knight. Hall and Knight. You can order this book. This book will be nice. Or for now, other than this, I don't think you need to buy any book. I will send you material or questions that when we do specific chapters in algebra, I will send you stuff that we'll use. Okay.
Okay.
But if you can buy this book, you should have this book. This is a very good book. Okay. So this is also a very old book, 100 years old. Similarly, for calculus, there's a book by this Russian writer called I.A. Maron, Problems in Calculus in One Variable. Problems in Calculus of One Variable. Of one variable. So just write down the names of these four books. These four books you should definitely have. These are all not very expensive also. You should get these books because these can be your reference things that you will use later. Okay. Anytime you are stuck on something, you can refer to these books and try to understand what is going on. Okay.
Yes,
And
sir.
definitely you need textbooks apart from what the Matra Academy book is. Okay.
Yeah.
Because if you realize by now, you would have realized that that book is not sufficient. It is just a collection of questions, right?
Yeah, sir.
It's not working out, no? I mean, you are trying to do it, but it's not helping a lot, right?
Yeah.
So it will have a set of results in the beginning and then questions, right? That's it, right?
So like our sir solves it for us. Like
Huh,
whatever questions we have doubts, we
huh.
can ask him and he solves it for us. But there
Okay.
are no like solved examples before the.
So that Amatra book is just a set of results given in the beginning and then sees a series of questions, right? Per
Yes.
chapter.
Yeah.
Correct. So
Yeah.
so that is not a proper textbook, right? It's not a textbook. You cannot read from there.
Yeah.
Okay. So at home when you're preparing maths, you should be reading from some source which is explaining something. Okay. You should not be it's maths is not just about solving questions. Maths is also about understanding what is going on, right?
Yeah.
There is something going on in each chapter which you need to understand. There is a logic to it. Okay. It's not just like practice, 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 and do questions. Okay.
Yes.
So you need a theory book. You need a basic book for each subject in maths. So if these are the four major divisions, these are the four major divisions of 11th and 12th. Okay. So trigonometry, coordinate geometry, algebra, calculus. Okay.
So
So if
these
you have one, huh? Tell me.
so these books are for both 11th and 12th.
Yeah, it will have everything.
Okay.
So these four books will be useful for your 11th plus 12th. Okay. It is good enough for JEE mains and all. Nothing beyond this can come in JEE mains. These four books.
Okay.
Okay. So uh, it will be useful throughout, and whenever you are stuck on anything, you should be able to go to a chapter and figure out what the author is saying and trying to explain. Okay. You have to have some reference books.
Yes.
These are very good reference books. It will much better than those. Disha book is also not a textbook. Okay. It's a collection of problems, right?
Yes.
Disha book doesn't have much theory, no? It will just have some objective questions, right?
Yeah. So
So definitely buy this book. These four books, you will use them and you will need them, and we'll refer to them whenever needed. And otherwise, what we will do right now is come up with a plan for how we go about this. Okay. So uh, depends on what chapters are weak for you and what is upcoming in your school, like what is going to happen in the next week, or when is your next test, or depending on that we can tailor our schedule according to that. So
okay.
you have to tell me some information. So look, what is happening right now and what is likely to happen in the next few weeks?
So I'm not sure, but I think we'll be doing quadratic equations.
Okay, quadratic equations uh, is going to be done soon. And
I'm not sure,
but when
but
is your next maths test?
it's next Tuesday.
So that syllabus for next maths test is what?
Relations and functions
Hmm.
and sequences and series.
Okay, so for till next week at least we'll only focus on this
Yes.
plus sequences and series. So let's spend the remaining time this week and next week on this only, and so that you are slightly better prepared for that chapter. Okay.
Yes.
So that test. So I want an improvement in your scores, and so that you feel more confident in maths. So sequence and series is theoretically done for you.
So
In your
I don't remember the formulas very well. Like, and there are
okay,
some extra things that are not there in NCRT, like AGP.
uh, it's
Uh,
not very difficult. Okay,
yeah.
so let's just discuss. Do you have doubts in that chapter? Do you have many questions that are problems?
So not yet because I haven't really tried it
Okay.
because we just started doing the competitive level questions for them.
Uh,
And yeah, and I have chemistry exam on Tuesday.
okay. Okay.
So I was
Okay.
planning on starting from Tuesday.
Do you have any doubts in relations and functions?
So like I haven't really understood the difference between domain and range. Like I know how to find it out when it's an arrow diagram, but
Okay, it's very
like
simple, dude. Okay, first we'll discuss relations and functions, and then we'll go to this. Okay, so there are two sets, set A and set B, right?
Yes.
Now set A has some elements 1, 2, 3, 4, and set B has some elements A, B, C, D, right?
Yes.
So a relation or a function is a this diagram, right? Your mapping is a mapping from set A to set B, right?
Yes, sir.
It could be a mapping like this, where you are saying that 1 and A is an ordered pair, 2 and B is an ordered pair, 4 and C is an ordered pair, and 3 and D is an ordered pair, right?
Yes.
Correct. So before we can understand relations and functions, you need to know what is the Cartesian product of two sets. What is a Cartesian product, or A cross B? You know that. A cross B. How do you write A cross B set? See, A set I can write how? A set I can write like 1, 2, 3, 4, right?
Yes, sir.
And B set I can write as A, B, C, D, right? Okay.
Yes, sir.
So A cross B set is the set of ordered pairs from A and B. Okay, so it will be a set like this, AB, where A belongs to A and B belongs to B. Okay. So what does that mean? Basically construct all possible pairs, okay, where first element belongs to the first set and second element belongs to the second set. Okay.
Yeah.
So for example, one pair could be 1 comma A, another pair could be 1 comma B, 1 comma C, 1 comma D, right? These are four pairs with one, right? First element.
Yes, sir.
Similarly, you can have 2 comma A, 2 comma B, 2 comma C, 2 comma D, and similarly you can have 3 comma A. You understand?
Yes, sir. Yeah.
So I am just writing out all the pairs possible with first element in the first set and second element in the second set, right? Correct. So the
Yes.
list of these are all ordered pairs. Why is it called an ordered pair? It's called an ordered pair because there is order to it. No, first element has to be in the first set.
Yes, sir.
Second element has to be in the second set. This list, this set of all such ordered pairs is called Cartesian product. Okay.
Okay, sir.
So you can quickly guess if the first set has m elements and the second set has n elements, right? The Cartesian product should have mn elements, right?
Yeah.
You understand?
Yes, sir.
Because m first elements can be there and n of them. For each m there are n, right? Choices,
Yeah.
right? So Cartesian product is very simple. So if I ask you A is 1 comma 2 and B is 0 comma 1. So what is the Cartesian product? A cross B is what? Tell me.
1 comma 0,
Hmm.
1 comma 1,
Hmm.
2 comma 0, and 2 comma 1.
So Cartesian product is actually itself a set. It's the set of these things, right?
Yes.
Set of these four ordered pairs, right?
Yes,
Correct.
sir. Yeah.
Okay. So now, do you understand what is the meaning of something called a subset?
Yes, sir.
Subset is a set that is inside another bigger set, right?
Yes, sir.
So basically, if I say A is a subset of B, right? That means every element of A is an element of B, but not vice versa,
Yes,
right?
sir.
There could be some extra elements in B which are not elements in A, right?
Yeah. Yeah.
It's a situation like this. This is A, this is B, right?
Yeah.
So now the definition becomes very simple. A relation is what? A relation is any subset of A cross B. Okay.
Yes, sir.
So right now you have A cross B here, no? So any subset, how many subsets are possible? Suppose there is a set which has n elements. How many subsets are possible?
Um,
How many subsets of A?
so and
No, subsets of A are 2 power n,
oh yeah, sir. Yeah, sorry. Yeah,
right?
yeah. Yes, sir.
You know this, no?
Yeah,
Uh,
yeah.
suppose A, B, C are three. A, B, C is my A, right? Number
Yeah.
of subsets of A could be like I'll list down the subsets. There is a null set, nothing, right?
Yeah.
Then there is A. This is a single element set, singleton set, right?
Yes, sir. Yeah.
Then B, then C. Then there are two element sets, AB,
Yes, sir.
BC, CA. And there is a final set which is itself, right?
Yes, sir.
A set itself can be called as a subset of A.
Yes.
And null set also, right? So total see 8 are there, no?
Yeah, sir.
So basically, if you have 4 here, total number of subsets, how many elements are there in A cross B? 4 here right now, no?
Yes, sir.
Total number of subsets are 2 power 4. 16 subsets are possible. Correct?
Yeah.
16 subsets are possible. So how many relations are possible? 16 possible relations. Okay.
Yes, sir.
A relation is basically any subset of A cross B, right? So any subset of this could be like this also. See, 1 comma 0 is itself a subset, right?
Yeah.
Or a subset could be 1 comma 0 comma 1 comma 1, right?
Yes, sir.
Correct. This is
Yeah.
also a relation. This is also a relation.
Yes, sir.
Okay. Now we'll come to functions soon. So the basic understanding is that there are two sets A and B. You construct the set A cross B, right? Construct A cross B, right? Are you understanding what I'm saying?
Yes, sir. Yeah.
And from there, any subset of A cross B, okay, is a relation, okay, and there is a special type of subset of A cross B is called a function. Subset of A cross B is called a function. So what is the relation between a function? What is the relationship between a relation and a function, right? A relation is any subset of A cross B. A function is a special subset of A cross B, right?
Okay. Yeah.
So
Yeah.
there is like some qualifying conditions, right? So what you can say is all relations are functions. No, all functions are relations. My mistake. All functions are relations, but not vice versa.
Yes.
You understand?
Yeah.
Because a function is a special subset of A cross B, but special subset of A cross B means it is some subset of A cross B is. Any subset of A cross B will be called a relation, right?
Yes.
But this doesn't have to be true. This does not imply, right?
Yeah.
But this implies it's a function, it's a relation, right?
Yes.
Okay, so now what we'll do is we'll try to understand what are the conditions under which you can call it a function, right? Why is it special, right? What
Yes.
is the special condition, right? So the best way to understand functions is through the idea of a machine, and this is an input and this is an output. So function is a machine. It takes in input and it gives out output. Okay, so
Yes.
it takes in some inputs, so you can feed it any number, suppose. Okay, so suppose x is the input, right? And output is given as y, right? So then you write it as y is equal to f of x, right?
Yes.
What is the meaning of this? That f is a function that operates on this input and gives out this output, right?
Yes, sir.
input, output. Think of it as input, output, and a machine. Okay. Now,
Yes.
what are the qualifying conditions of it being a good machine? First of all, one major qualifying condition is that if I input 1 to a machine, right, my output should be fixed, right? It should not be two on Sunday and 3 on Tuesday.
Yeah. Yeah, sir.
You understand?
Yeah.
For a single input, you cannot have multiple outputs.
Yeah, sir.
Then you will not be able to decide what it will do, no, the machine.
Yeah.
You cannot have multiple outputs. Okay. So this is the key understanding. A machine has to be reliable, right? Then only you can use it. So it cannot be like today it is giving, when you input 1, you get 5, and tomorrow it gives 10, right?
Yeah.
That
Yeah.
is not a good machine. That is not a function. Okay. So this is a major rule. Okay. For a single input, you cannot have only one output. Okay. So that means that if you give input X, you should get only one Y. For each X, only one Y, one value of Y.
Yeah, sir.
Correct?
Yeah.
This doesn't mean, this is allowed, by the way. 4 is giving you 2 and 6 is giving also 2. Right? This is fine.
Yes.
Why is this fine? Because multiple 2 inputs can give the same answer. That's fine.
Yeah.
It should not be that I give one input, I have multiple answers available.
Yeah, sir. Yeah.
You understand? This is a major condition. Also, the second point that makes functions a special type of relation is that for all inputs, you should get some answer. Should give some output. That means the machine should not just give up suddenly in the middle. If I input 1, I should get something out, right?
Yeah, sir.
It should not be like I gave in 1 and I got nothing.
Yeah. Yes, sir.
You understand? So all inputs should give some output. So for each X, there has to be some Y. Has to be some Y value output, right? So in terms of sets, this is how it looks. So there is a set A and set B, right? Okay. So this will be called my input set and this will be my output set. Okay. Now,
Yes.
first of all, when I give one value of X, I should get only one value of Y. I should not have from here 2 arrows coming out. Okay.
Yeah, sir. Yeah.
That should not be allowed. Okay. That is the first rule that we discussed earlier, right?
Yeah,
It
sir.
is okay to have multiple different things giving the same answer. That is all right. Okay. So for example, the machine can be doing a square, right? And -1, if you put X is equal to -1, you get Y is equal to 1. And if you put X is equal to 1, you get Y is equal to 1.
Yeah, sir. Yeah.
That's an okay machine. It is just giving X square, right?
Yeah. Yes,
But
sir.
this is not okay. Also, what is not okay is you have some elements in this. All of these had corresponding points and there was nothing for this one. You understand?
Okay.
This is like saying when you input 5, you get nothing.
Okay, sir. Yeah.
Right? All inputs should give some output. This is the second rule. Basically, every element in the input set should have some answer here, right?
Yeah, sir.
Some
Yeah.
output, right?
Yeah. Yes.
So these are the two rules. So from these two rules, we will be able to decide. So for example, let's take a simple example. A is 1, 2, 3, and B is A comma B, right? Okay. So first step in our relations and functions understanding was what? A cross B you have to construct. Okay. So tell me A cross B right now.
So 1A, 1B, 2A,
2A, 2B, and 3A, 3B, right?
Yeah. Yeah.
Okay. 3A, 3B. Okay. So there are how many elements in A cross B? 6.
Yeah.
6 elements in A cross B. So how many possible subsets are there? 2 power 6 subsets, right?
Yes.
So actually it is 64 subsets are possible, right?
Yes, sir.
So total number of relations will be, possible number of relations are 64. Any subset can be called as a relation, no?
Yes, sir. Yeah.
So 64 total possible relations are there right now. Okay. Now we have to identify which one is a function. So I will give you some example relations. Okay. So relation 1, 1b, 1a, that's it. Relation 2, 2a, 1a, 3a, right? Relation 3, 1a, 2b, 3c. Relation 4, 1a, 2a. Relation 5, 1a, 2b, 2a. What am I doing right now? I'm just putting some random subsets, okay?
Yes, sir.
These are just random subsets of A cross B, no?
Yes, sir.
Okay. Now, every subset of A cross B is a relation, right?
Yeah.
So, see, this is a relation, this is a relation, everything is a relation, right?
Yeah.
But now you will be able to tell me which ones are functions and which ones are not functions, okay?
Yeah.
Look at relation 1, relation 1, right?
Yeah. So it's not a function.
Because 1 is giving 2 possible outputs, no?
Yeah.
So clearly 1 can be B also, 1 can be A also, not a function,
Yes.
right? Second one,
So it is a function.
it is a function because the two rules are not broken, right?
Yes, sir.
The two rules, there are only two rules for being a function. One rule is that you should have only one output for each input, and the second rule is all possible inputs should give some answer, some output, right?
Yes, sir.
So none of the rules is broken in this. This is fine. This one,
So this is also a function.
this is also a function. This one,
Yeah, so even this is a function.
no, this is not a function. Think. What about 3?
Oh yeah, so like so okay. No, sir, I didn't get why. So because does two also need to have its own output?
2 has an output. Think about it. Think of the two rules, dude. What are the two rules? This function looks like this, no?
Yeah.
Why is it not a function, am I saying? What about 3? Is there a value for 3?
No, sir. But there's no three, right?
That is the point. That's why it's not a function. What about the 3 input, dude? 3 is an input, no?
Oh, okay. Yeah, sir. Yeah, I got it. Yeah. Yeah, sir. I understood. Yeah.
That is the second rule. All the things in the input set should have some answer, right?
Yeah, sir. Yeah, I understood.
Okay, there are two rules only. One rule you have understood, but the second rule you have missed here,
Yeah, sir. Sorry.
right? So the second rule is what? Second rule is saying that every element in the input set should have some answer, right? Here,
Yes.
if I input 3 to this function, it's not a function because nothing comes out of 3, right?
Yes, sir. Yeah.
Right? Here,
So this is not a function.
because 2 has multiple values, also 3 is not even given,
Yeah, sir. Yeah.
right? Not a function because it breaks both the rules,
Yeah.
right? Okay, so now, so all of them are relations, but only 3 of them are functions, right?
Yes, sir.
This is function, this is function. Actually, 2 of them are functions, right? Out of the 5 I randomly created, 2 came out to be functions. Okay.
Yeah.
So you understand that relations and functions are all related to this A cross B thing, right?
Yeah, sir.
Relations are any subset is a relation, any subset, and functions are special subset, right?
Yeah, sir.
So and you know the two rules by which the special subset becomes special, right?
Yeah, sir.
Correct. Now we'll just talk about them in terms of sets like this. So if you write a function from A to B, right? Now this set is called the domain.
Yeah, sir.
Domain is basically set of inputs.
Yeah.
Okay. And the whole set B, this set B is called the codomain. This is the possible set of outputs. Possible set of outputs, not the actual outputs. Okay. Possible set of outputs. Why am I saying that? Why am I saying that? Because see, A, B, C, it could also have a D, and I could have a function like this. Okay.
Yeah.
Okay. So B set has A, B, C, D actually. Okay. B set is what? A, B, C, D, right?
Yeah.
But actual outputs are only A and B and C,
Yeah,
right?
sir.
D is not coming anytime, right?
Yeah.
Notice that this will be a function. If I write this relation as a list of ordered pairs, I would have written 1A, 2B, 3C, right?
Yeah, sir.
And this is okay because each of them has only one output and all of the inputs are covered, right? All of the inputs have some output, right?
Yes, sir. Yeah.
So it is fitting my two rules to make it a special subset, right?
Yeah. Yes.
So this is a function, but notice that nothing is there for D, no?
Yeah. Yes, sir.
Right? So B set is called codomain. It is the possible set of outputs, the actual set of outputs, right? Whatever comes from the function, right, is called the range.
Yes.
Okay. So here range, I will say range set is equal to ABC. Codomain is the B set, right?
Yes, sir.
Which is ABCD. Okay.
So, but how can the machine produce an output if there is no input? Like, how can
It
it do
cannot.
D?
D will not be produced.
Okay,
What
sir.
are you talking about? Tell me.
No, like,
Explain.
how is there a D in the B set?
No, because for example, I can say a function from real numbers to real numbers, right?
Yes, sir.
And the function is defined by y is equal to x square, right?
Yeah.
Okay. Now, y is equal to x square. That means this initial set can be real numbers to real numbers, right?
Yeah.
Okay. So
Okay, sir. Yeah, I understood.
all real numbers can come here and all real numbers can come here. Okay.
Yeah, I understood, sir. Yeah.
Wait, 1 second. Hold on. This is all real numbers. Okay. Negative, positive, everything, right?
Yeah.
So every number will have a square, right?
Yes, sir.
Right. Every real number square will be available, no? Like
Yeah.
no matter what number I take here, right?
Yeah.
Correct.
Yeah.
But you notice that many real numbers have nothing here, right?
Yeah.
Because these are -1, -2.
Yes, sir. Yeah.
So it is okay, it is possible. You can make a big set like this. This is the big set. This is called R is the codomain. Okay.
Yes.
And
Yeah.
this is the domain. And this is domain is easy. It is set of inputs,
Yeah.
set of allowable inputs, right?
Yes, sir.
Codomain is possible set of outputs, but actual outputs might be very small compared to the possible set,
Yes, sir.
right? If I had written the same thing like this, z to z, z is suppose set of integers, right?
Yes, sir.
Then notice that z to z, right? And the same function, y is equal to x square, right? So 1, 2, 3, 4 are my integers here, no?
Yes, sir.
And -1 also, but I'm ignoring that. Okay.
Yes.
Actually, just write -1 also. -1, -2, and so on, right? And -1, -2 are my values here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Possible set of integers, right? Notice that every integer will have a square,
Yeah. Yes, sir.
right? So everyone will be covered here, right? 3
Yeah.
to 9, right? But very few of them will have connections, no?
Yeah. Yeah. Yes, sir.
Like only 1, 4, 9, 16 and all will have some arrows pointing to them, no?
Yeah.
Right?
Yeah. Yes, sir.
So very few of them could have possible output set could be much smaller than the B set, codomain set.
Yes, sir.
Okay, so actual outputs are called range, and possible outputs are called codomain, right?
Yes, sir.
So generally what you have is range is a subset of codomain, right?
Yeah. Yes.
Sometimes it could be equal. Sometimes it could be range is equal to codomain. Like if I, in the earlier examples that we were seeing when it was 1, 2, 3 ABC, right?
Yeah.
Range was equal to codomain. Everything was covered, right? But in the example where I just drew A, B, C, D, range was not equal to codomain. Range is a subset of codomain now,
Yes, sir.
right?
Yeah.
So are you understanding the domain, range, codomain terms and all?
Yeah, sir. I understood this, but like,
Hmm.
if they give us a function
Hmm.
and they ask us to find the domain,
Hmm.
I like,
Give some examples of difficult questions that you're facing issues in.
yeah. So 1 second.
You can message me on my number, or again WhatsApp you can send it.
So I can just say it here. F
Okay.
of x is equal to whole
Hmm.
root 9 minus x square.
That's it, huh?
Yeah, so like I know how to find like,
So let's understand it. F of x is equal to whole root 9 minus x square, right?
yeah,
So what you understand is, right now you should understand that domain means set of allowable inputs, right?
yeah,
Allowable inputs.
yeah,
Okay. Codomain you can never figure out, by the way, right? Codomain has to be given to you,
yes, sir.
right? It cannot be that possible set of outputs you cannot ever say. Codomain has to be given to you in the question. You understand?
Yes, sir.
Like if they say function is from A to B, right? A is the domain and B is the codomain, right?
Yeah, yeah,
Sometimes they write notation like this, no, A to B like this,
yeah,
right? Range is something that you can figure out. Actual outputs possible,
yes, sir.
right? Okay.
Yeah,
So these three things you need to know, like this understanding you need to have, that set of allowable inputs, right, is domain, right? So what is allowed here, right? So the function's nature could preclude or exclude some possible inputs, okay, which is the case here. Here the function has a square root, right?
yeah,
Now inside a square root, if I put x is equal to 5, then it will be weird stuff.
yeah, sir.
It will be minus 16 or all, no?
Yeah,
Which is not defined, at least in the set of real numbers,
yeah,
right?
sir. Yeah,
So you know this fact that inside a square root it should be positive, right? So you
yeah,
know that 9 minus x square has to be greater than equal to 0 for it to make sense in real numbers, right?
yeah, sir.
So therefore now x is allowed to be only some values, no? X can only be from minus 3 to 3, right?
Yeah, yeah,
You understand? X can only be from minus 3 to 3, and x was supposed to be the input variable, no?
yeah, yes, sir.
Y was the output variable, x was the input variable, right?
Yeah,
So the function's nature itself is disallowing so many values, only this much is allowed, right?
yeah, Yes.
So you can construct many types of functions. For example, if I had 1 by x, right? Here,
Yeah.
the nature itself does not allow division by 0,
Yeah.
right? So x cannot be 0. It can be anything else, right?
Yeah, sir.
So this is the problem, that the function itself by definition does not allow certain values, right?
Yeah. Yeah.
So you can have a combination of this. Suppose you have sine of uh, 1 second. Suppose you have fx is equal to root of 9 minus x squared plus 1 by x, right?
Yeah.
So
Yes.
so now see, there are two conditions imposed, right? Here this implies that minus 3 should be less than x, should be less than 3, right? And this implies x should not be 0, right?
Yes, sir.
Correct. Now both the conditions have to be true together to give any sensible function, right?
Yeah.
It
Yeah.
cannot be I get, okay, this is fine, but this is undefined, right?
Yes, sir.
So both the conditions have to be true together. So there is an and, right? So it has to be in an intersection, right? Intersection basically of these two conditions, right?
Yes.
These two things are true only if x is like this, less than x is less than 0, union 0 is less than x is less than equal to 3. Basically you're excluding the 0, right?
Yeah, sir. Yeah.
Right, so you're
Yeah.
making sure that this condition is also true and this condition is also true. So that will be the set of possible allowable input. So that will be the domain, right?
Yes, sir.
Okay, so this is not a very difficult question. So give me any other questions that have been bugging you here, anything that is hard.
So like I haven't really understood how to differentiate between finding the range and range and domain.
See,
Like,
now you have understood. No, don't go by the old confusion. See, old confusion before the class, you did not know what was the difference, right?
yes, sir. Yeah.
But now do you know the difference? What is the meaning?
Yeah, sir. Yeah.
You know the meaning. No, meanings are completely different, no?
Yeah. Yes, sir.
Right?
Yeah.
Like, you should not be now confused that what is the domain and what is the range, right?
Yes,
See,
sir.
even if you don't know how to find the range, at least conceptually you know that they are different things, no?
Yeah, sir.
Right?
Yeah.
Domain should be the allowable x values, right? Possible x values, right?
Yeah.
Possible input values.
Yeah.
That is called domain. And range is what? Range is whatever comes in that other set, no?
Yeah, sir.
This part is the range, no?
Yeah.
Right? So range is set of possible outputs, right?
Yeah.
Actual outputs, not possible output. Possible outputs is codomain, right?
Yes, sir.
Do you know, do you understand this, or are you just saying yes?
No, sir. I understood.
So set of actual outputs, right? That is what my range is, right?
Yeah, sir.
So let's try to figure it out. Like now we'll know what to do. Now we'll try to find it for this particular function. So there is no one method to find range. It comes by practice and just looking at different functions and thinking about it. There is no standard method. Okay. So
Yeah.
if I have this function, let's try to figure it out for ourselves. What should be the range? Possible inputs was what? -3 to 3, right?
Yeah, sir.
This was my domain. So basically, I should not try to figure out range for x is equal to 4, right? That is not allowed only.
Yeah. Yes, sir.
You can only give inputs to this machine from -3 to 3, right?
Yes, sir.
So why don't you try to putting some inputs? X is equal to 2, what comes? It becomes √5,
Yeah.
right? X is equal to 1, it becomes, y becomes √8, right?
Yeah.
Right? Correct.
Yes, sir.
So similarly, sorry, x is equal to 0, y value becomes 3, right? √9, right?
Yeah. Yes, sir.
uh, Whatever you put, right, the square root is always defined, as a positive sign, mod x. This you need to, when you write a square root like this, no, that you mean plus only. You don't mean -3. If I
Yes, sir.
do √9, I will not say -3 because this means plus.
Yeah.
If I had to refer to the minus √9, I would have written like this. That would have been -3.
Yes, sir.
Okay. So notice that because it is plus here, can you ever get a negative answer here? It's not possible,
No.
right?
Yeah.
You can check any value. X is equal to -2. Y will be equal to 9 minus 4 again √5, right?
Yes, sir.
You can check any possible values. You will see that y value is always greater than equal to 0. It can be 0 at one time, x is equal to 3 or
Yes, sir.
-3, right?
Yeah.
And what is the maximum value that it can be? It can be 3, no, maximum, when x is minimum, right?
Yeah.
Right?
Yeah.
Why is that the maximum value? Because x square is always positive, no?
Yes, sir.
So if you're subtracting from something and if you're subtracting a positive thing, it will always reduce it, right? Unless that square is 0, right? If you're
Yeah.
subtracting 0, then that will be the highest, right?
Yeah.
So the values of y can go from y can become greater than 0, but y cannot be more than less than equal to 3. It will be, no?
Yeah. Yes,
Right?
sir.
That is clear by trial and error, right? And
Yeah.
a little bit of thinking, you realize that it cannot be greater than 3, right?
Yeah, sir. Yeah.
So that is the actual possible outputs are 0 to 3, right?
Yeah, sir.
Actual outputs are 0 to 3. So that is the range.
Yeah, sir. I understood.
So basically, I mean, there is no connection between range and domain. Okay. So you should not never be confused by it. It's not like two close concepts, right?
Yeah, sir. Yeah.
So domain is something completely different. Range is something completely different, right?
Yeah, sir. Yeah.
So this set is domain and this set is range, right?
Yes, sir.
And it could have some others also. This whole set is called codomain.
Yeah.
This whole set is called domain, right?
Yes, sir.
So there's nothing to be confused about. If you have function given as a something written like this, you can give me some example from your book which looks difficult. Just look through your book and select some question.
Yeah, sir. 1 second. So, function is equal to 1 plus, like, I haven't done these questions, so I don't know.
But just tell me anyway. We want to discuss one or two examples so that it's clear.
Function is equal to 1 plus 2 to the power x by 2 to the power x.
Okay. Okay. So this is the function. You have to find domain and range, right?
Yeah, sir.
Okay.
So domain can be open, closed, open interval 0 and closed interval infinity, right?
1 second. Just hold on for a second.
Yes, sir.
So think about it. Don't think about what the answer is going to be. Let's just right now see in our classes what we will focus on is one or two major things are we don't care about the answer, at least in the beginning, right?
Okay, sir. Yeah.
We don't care about the answer. What I care about is whether you are understanding it and whether you are actually proceeding or trying to do the question in the right way.
Okay, sir. Yeah.
The right way to do the question. Right way to do the question is proceeding from the concepts, definitions. Right way, what is the right way? Like work from knowledge of definitions, from definition, basic definitions. We'll keep using them and we'll keep using them again and again, and we'll keep reinforcing our ideas. So once you learn how to work from these basic principles, then answers will come, dude. That will happen. Okay, so don't worry about the answer, worry about what is being asked and do you know what it means, right? So
Yes, sir.
domain is being asked first, right? Domain. So
Yeah.
domain means what? Domain is possible inputs, right?
Yes, sir.
Possible inputs. Okay, so let's think about inputs. Inputs means values of x, right?
Yeah.
X can be what, right? That is the question, right? Correct.
Yeah.
So okay, so let's look at this function a little bit. Is there any restriction on x? See, whenever there is a fraction, right, a
Yeah.
by b, I am always worried about whether denominator can be 0, right?
Yeah.
If it's
Yeah.
a fraction, then denominator could be 0 and it could be undefined, right?
Yeah.
But here, 2 power x, can 2 power x be 0?
No, sir.
It's not possible, right?
Yeah.
2 power x, whatever you do, like the only possible way to make it 0 is x tends to minus infinity, right? But that is not a real number.
Yeah.
Minus infinity is not a number, it's just a notion. It's an idea that if x is very small,
Yes, sir.
negative, then it will be 2 power x will be 1 by 2 power x and almost 0, right?
Yeah, sir. Yeah.
So there is no way that you can make this denominator disappear, right?
Yeah.
So then is there any possible restriction then? Then there is no problem, right?
No, sir.
The only problem that would have come on the x value would have been when denominator would have been 0, right?
Yeah. Yes, sir.
Right? So there is no issue in the possible inputs, right? So I will just say x belongs to real, right?
Yeah. Sir,
Like,
but this question they haven't asked domain or anything.
what have
They've
they? Strange.
asked if it's even or odd or
So those, so right now we are discussing, I thought it was a domain range question,
yeah,
but
sure. It was my mistake. So I didn't see the
but it's fine. Even, odd, and all will come later. Right now, let's just work about domain and range,
Yeah,
and
sir.
after that, we'll see the even, odd, and all.
Yeah.
So domain is x belongs to real.
Yeah.
Now let's think about the range. Okay, range. Range is what? The meaning of range was what? This set outputs, right?
Yeah, sir.
Actual outputs can be what, right? That is the question. So basically y values, right?
Yeah, sir.
Y values are what are the y values, right? So if you look at the function closely, you can divide, right, by 2 power x and separate the fraction, no?
Yeah.
You can write it like this, right?
Yeah.
So clearly 1 plus 1 by 2 power x, right?
Yeah.
So notice that y is equal to 1 plus this, right?
Yeah.
And can 2 power x ever be negative 2 power x?
No, sir.
No matter what you do, it will be positive, right?
Yeah.
So first of all, you have realized that y value is 1 plus something positive. Right?
Yeah.
So therefore, y is definitely greater than 1, right?
Yes, sir.
Right? And
Yeah.
what
Yes.
is the size of this something positive that we are adding? It could be very small.
Yeah.
If x is minus 100, suppose, right?
Yeah, sir.
Then it will go on top. It will become very large, no?
Yeah.
Or if x is 100, then 1 by 2 power 100 is almost nothing, right?
Yeah.
So basically it can go from 0 to infinity, no?
Yeah. Yes, sir.
If you put a x value of very small or very negative, right?
Yeah. Yes,
Then
sir.
notice that it will go on, come up on top, no?
Yeah.
And therefore it becomes a huge number, right?
Yeah. Yes, sir.
So basically it can be 0 to infinity, anything. So the only thing you know is that y is greater than 1, right? After that, anything is allowed after that, right?
Yeah.
So the range will be y greater than 1.
Yes, sir.
Okay.
Okay.
Basically 1 to infinity, right?
Yes, sir.
So domain is real numbers, range is 1 to infinity. Now even, odd functions and all, if you want to do 2 power x plus 1 by 2 power x, right? What
Yeah.
is an even function? Again, before we can do any questions, we want to focus always on, do we know the meaning or do we really know what an even function is? So do you know what it is?
No, sir. No.
You don't know right now?
No, sir.
Okay. This chapter has been done in class, no? Finished.
No, sir. We like just started.
Okay. Just started right now. Okay, do two parallel tracks. So this is one of the tracks.
Yeah, sir.
Okay. So even and odd functions have a very simple meaning. For example, I will give you two examples. This function, graph of this function, y is equal to x square, right?
Yeah.
So notice that x is equal to 1 gives y is equal to 1, right?
Yeah.
And minus 1 gives y is equal to 1 also,
Yeah.
right? So the values of f of 1 and f of minus 1 are same, no?
Yeah, sir.
Right?
Yeah.
So basically the whole graph this side is the same as this side, right?
Yeah, sir.
It's like a reflection on the y-axis, no?
Yeah. Yes, sir.
Y-axis reflection, right?
Yeah.
That type of function is called an even function. Basically, the definition of even function is f of minus x should be equal to f of x.
Okay, sir. Yeah.
Basically, if you have some input x and if you take negative input, the answer is same, then it's even function.
Yeah, sir.
Okay.
Yeah.
And odd function is y is equal to x. So notice if you take x is equal to 1, your answer is 1. X is equal to minus 1, your answer is minus 1. No?
Yeah. Yeah, sir.
Correct. So odd functions are basically functions. When you take minus x, it becomes minus of f of x.
Okay,
Okay.
sir.
Okay. So basically, examples are y is equal to x, y is equal to x cube. Let's check whether x cube is an odd function. What do I do to check? I put, instead of x, I put minus x, right?
Yeah.
So what comes out? Minus x to the power cube, right? Which is minus of x cube, right?
Yeah.
Which is minus of fx, right?
Yeah.
So
Yes.
f of minus x is minus of fx, then it is called odd. And if f of minus x is same as fx, it's called even, right?
Yeah, sir.
So notice that for odd functions, what you're getting is it is a reflection on the origin. Whatever is this side is the same this side,
Yeah, sir. Yeah.
right?
Yes, sir.
We will come to this later. I mean, you will be doing this in class anyway. So,
Yeah, I'll brush up on all these topics.
so right now let's just check whether this is even or odd, right? So
Yeah.
this is my function. F of x is basically 2 power x plus 1 by 2 power x. So to check even or odd, by the definition, I will just find out what is f of minus x, right?
Yeah.
That should be 2 power minus x plus 1 by 2 power minus x, right?
Yeah.
Okay. So this becomes, now 2 power minus x can be written as 1 by 2 power x plus 1 by
Yes.
1 by 2 power x, right?
Yeah.
So when you add it, convert the fraction into normal, it becomes this by 2 power x only, no?
Yeah, sir.
Because this will cancel, no, denominator.
Yeah, sir. Yeah.
So now notice that this has become same as fx, right?
Yeah, sir. Okay.
So
Yeah.
this is clearly even,
Yeah, sir.
right? So again, main thing to know is that definition you have to be super clear on. Okay. So that is why we spend so much time on what is a Cartesian product. What is it, right?
Yeah.
Cartesian product. Then what is a relation? What is a function? Like these terms, right? What is domain? What is codomain? What is range, right?
Yeah, sir.
Then came even and odd. What is even odd? There are other things also in this chapter. What is into? What is onto? One, many one. These are types of functions. Okay.
Okay, sir.
These are special types of functions. Has this been done in school?
So I don't know about into also, but
Not yet
yeah,
done.
like we have in our book we have modulus function, signum function, greatest integer,
Mhm.
and then quotient of
Those are just different special functions.
Okay,
Into onto is a concept. So into onto and one many one is a
Yeah.
concept. So it's an idea. So sorry. So right now you don't know their meaning.
No, sir.
Okay. So and you don't remember it being done in class and all.
Yeah, sir. I don't think it's been done.
Okay. So we'll just quickly discuss what is one and many one. Okay. One and many one is super easy to understand. Okay. So this is function a to b, right?
Yeah.
-1 gives 1, 1 gives 1, right? 2 gives 4. I'm drawing the y is equal to x square function, right?
Yes, sir. Yeah.
So you see, -1 gives output 1, 1 gives output 1, right?
Yes, sir.
So this is called a many to one function. See, two values of y are giving same value of x. Two values of x are giving same value of y, no?
Yeah, sir. Yeah.
Right? Clearly, like -x is going to give same as x, right?
Yes, sir.
So this is called a many to one function, right? You could also have, you remember earlier we had done an example where 1, 2, 3, a, b, c, right?
Yeah.
And there was a function that we had written like this:
Yes, sir.
1a, 2a, and 3a, right? That is also a function, no?
Yeah. Yes, sir.
Because all the three inputs are covered, right?
Yeah. Yes, sir.
And but they are all going to the same number. That is fine,
Yeah.
right? That is okay to have many to one. So this is a many to one function, okay?
Yeah. Yes, sir.
One to one function would be when this is not happening, when only one value for each, right?
Yes, I understood, sir.
So one to one and many to one is clear. One to one is like this. Many to one is like this,
Yes, sir.
right? That is simple. Then we come to into and onto. Into and onto functions. So suppose we have some function here: 1, 2, 3, a, b, c, d, and another function here: 1, 2, 3, a, b, c. Okay.
Yes, sir.
We have seen these functions before. This
Yeah.
was like this, like this, like this, and this was
Yes.
like this, like this, like this. Okay. So this function, right, is
Yeah.
called an onto function because all codomain values, right? All codomain values have a input,
Okay, sir. Yeah.
right? On the other hand, here D is unattached to anything, right?
Yes, sir.
D is unattached. There is no input value which gives output D, right?
Yes,
We
sir.
have seen examples of that. For example, y is equal to x square from f is from real to real, right?
Yeah,
We
sir.
saw that so many real numbers have no inputs, right?
Yeah.
Negative real numbers have no inputs, no?
Yes, sir.
So that is called an into function. Okay. Onto function will be the type where everything in this set, right, has an input.
Yes, sir.
You understand?
Yes,
So
sir.
basically the difference can be understood when you talk about the terms range and codomain. Okay.
Yes, sir.
So onto function means range is equal to codomain.
Yes, sir. Yeah.
And into function means range is smaller than codomain. Range is a proper subset of codomain.
Yes, sir.
I'm not drawing the subset symbol because subset symbol has a equal set also itself, right?
Yes, sir.
Proper
Yeah.
subset means it's smaller.
Yeah. Yes, sir.
So if you have a situation where there is some element in the codomain which has nothing here, right? Then
Yeah.
that is called an into function. And if you have a situation where range and codomain are actually same, right? Then that is called an onto function. Now
Okay.
that, so example of onto function would be this: real to real y is equal to x square, right?
Yeah, sir.
Correct.
Yeah.
But if you take, for example, real to positive real, right?
Yeah, sir.
I have written r positive and y is equal to x square only, right? All positive real numbers will have a square root. No?
Yes, sir.
You understand?
Yeah, sir.
Okay, wait, I'll just do this on this page nicely. So, for example, right now it was real and this was also real, okay? And this was minus 1, 1, 2, 3. This was 1, minus 1, 2, 3, so on, right? You can clearly see that square value will be like this. 2 and all will have some values, right?
Yes, sir.
2 and all will have some connections, but nothing will connect to minus 1. No?
Yeah.
This minus 1 will be left alone here. No, nothing can come from that side, right? To be
Yes.
minus 1, right? Because
Yeah.
the function is y is equal to x square, right?
Yeah, sir. Yeah.
So this will be an example of a function which is into, right? Because here the range is a proper subset of codomain, right?
Yeah, sir.
All the negative numbers will not have anything here, right? But
Yes.
if I change just these two sets, right? If I do real to real positive, right? Then this set is same as before, right? But this set only has 0, 1, 2, 0.5, 3, 4, and so on, right?
Yes, sir. Yeah.
Only has the real positive numbers, right?
Yeah.
So now you notice that every real positive numbers will have a corresponding thing. No?
Yeah.
There will be a 0 here which will connect to this. There will be a root 2 here somewhere, right?
Yeah.
Every positive real number definitely has some input here, right?
Yeah. Yes, sir.
So there is nothing here that will be excluded now, right?
Yeah. Yeah.
You understand? Everything here will be covered, right?
Yeah.
So then you will say that range is equal to codomain.
Yes, sir.
So this function is now onto, right? Notice that it's the same function y is equal to x square, right?
Yeah. Yes, sir.
So what decided that it was into or onto? This decided it, right?
Okay, sir. Yeah.
You understand?
Yeah.
The
Yeah.
actual codomain set decided it, right?
Yeah, sir.
Correct.
Yeah. Yes.
So it doesn't depend on whether it was y is equal to x square. No, see, same function has become into here if you are taking real to real, right? But
Yes.
if you're taking real to positive real, it became onto, right?
Yeah. Yes, sir. I understood.
So always, again, definitions are important. Onto means range is equal to codomain. Into means range is a subset of codomain, and understand it pictorially the way we have understood right now. Okay.
Yeah, sir. Yeah.
So okay. So functions and all, conceptually, I don't think anything else is there. There will be conceptually, there might be something called transitive relation, equivalence relation, and so on. Transitive, reflexive, symmetric in your NCRT, right?
Yeah, sir.
Symmetric type of relations. Okay. In your NCRT book, there might be these things. So, have they been covered in your class, this thing?
So 1 second.
Equivalence relations.
Uh, uh, no, sir.
Okay. So what I want you to do is
Sure, if these are there in NCRT, I'll go through it.
so right now, actually, what you should do is figure out what is your exact portion for the test. Okay. And
Yes, sir.
next Tuesday's test, if it is sequence and series, how much is coming, and if it is relations functions, what is coming, right?
Yes, sir.
Relations and functions. figure out the exact syllabus and actually go through the entire chapter from your NCERT and wherever else you have theory book right now, right?
Yeah.
And your results in your Matra book, right?
Yeah.
In your Matra book, right? So I want you to collect a set of doubts, okay?
Okay, sir. Yeah.
Collect a set of doubts and issues that you have, right? So that
Yes.
in the next class we can like actually fix those, right?
Yeah.
Okay.
Yeah.
So
Yes.
basically the point is that you need to be very well prepared for the class, okay? Like
Yes.
very well prepared for the class in terms of what are the things you need to ask and what are the things that you need to sort out immediately, right? It should
Yes.
not be that we are searching for things, okay? In the class it should not be that we are searching for what to discuss now, right? You should have so many things that you need, right? Then we'll
Yeah.
quickly go through them, okay?
Yes. Yeah.
And uh, we'll just focus on this in the next class, these two chapters. I want you to do as many questions as possible, do as many questions as possible, and
Yeah.
collect all your doubts, mark them in your book, whatever, however, right? And
Yeah.
figure out what you need to ask. Try to do the tough questions, try to do the JE level questions,
Yeah, sir.
so that you need to figure them out before the test, right?
Yeah, sir.
So in this week, every week, like right now when we'll do the classes, every week what you should do is make sure that you are doing the difficult things in the week so that you can ask me on Saturday, right?
Yeah, sir. Okay.
Okay. So
Yeah.
this week just focus on the questions from here and here,
Yeah.
and keep in mind, uh, we don't care about the answer, we care about why we are understanding it, okay?
Yeah, sir. Yeah.
So it doesn't matter if you got the answer, it doesn't matter if I know some method to do it. What matters is, can you figure out on your own, is it making sense to you, is the picture becoming clearer and complete and interlinked, or is it becoming more muddled, right? It should not be like that, right?
Yeah, sir. Yeah.
Maths is not going to be a subject where you have a whole bunch of techniques and you just have to use some technique here or something here. It's not a collection of haphazard things, okay? It's
Yeah.
all linked together and it's very logical, okay? So
Yeah. Yeah.
the connection should start showing, like you should feel like, okay, I know what is going on in this chapter, whatever is asked I can figure it out, right? That
Yes.
should be the feeling that you should try to develop. So don't when you are working at home also, don't worry about the answer per se, worry about, do you know the meaning? Like, do you know what the question is asking you? Do you know every term in the question? If you know every term in the question, what is the point where you're getting stuck at, right?
Yeah, sir. Yeah.
Okay, so uh, work from a first principles approach. First principles approach means as if you are beginning from scratch, right? So
Oh.
like whenever you are solving a question, there might be some shortcuts and all that you might have seen somewhere, right?
Yeah.
But right now in our classes, we'll not be focused on those shortcuts, because right now is not the time. The time is for us to be conceptually very thorough and very clear, okay?
Yeah.
So always do a question as if I know the definition, how can I find this out? And I don't have any other resources, it's just me and my intellect and my understanding, that's it, right?
Yeah,
I
sir.
don't have some example which I will copy and do it, you understand?
Yeah.
So examples are good sometimes for difficult questions, but actually ultimately you have to solve them, no, in the exam. Doesn't matter.
Yeah.
And you cannot remember all possible examples, right?
Yeah. Yeah.
Maths cannot be done like biology or chemistry or something, okay?
Yeah. Yeah.
Maths has to be done in a way where it makes sense and you can figure it out on your own, right?
Yes.
So this is the approach that you should keep in mind and work on these two chapters. Get as many doubts as possible, find out whatever is difficult. We want to fix that in Saturday's class next week, okay?
Okay, sir. Yeah.
Okay.
Yes.
And definitely order those 4 books. I hope you have written them down.
Yes,
Order
sir.
those 4 books, that will be useful for the next 2 years, okay?
Okay.
And get those books, that will be nice for you. So we will refer to them whenever needed, when we want to discuss something and all, Okay.
Yeah, sir. Yeah.
Okay. That's it for now. Next week we'll continue with this and we'll prepare for that exam. Okay.
Yes, sir. Thank you.
And try to find out as much information as possible from your school about the schedule of lessons and what is their maths plan, right?
Okay, sir. Yeah.
Like you can ask your teachers, no, okay, sir, what are the topics we'll do, what is the sequence, and like how to prepare and all. You can just ask them, right?
Yeah, sir. Yeah.
So just if you can get a sense of the calendar of topics and all, no, then we will also be able to plan out something, right?
Yeah, sir.
Otherwise it will always be playing catch up, so we want to not do that. We want
Okay,
to
sir.
have our own plan which ties in with your school thing, right?
Yeah, sir. Yeah.
Okay, I'll see you next week then.
Thank you, sir.
Okay, bye.
Bye, sir.